Hello everyone, thanks for tuning in. My name is Jesse, and I'm here to talk about the visual regression test in React Native. Here's our agenda for this session. First, I'll be giving a little introduction of myself. Then I'll be going through what visual regression test is all about and how it can be performed on a React Native project. Then I will conclude this session by showing an actual demo of visual regression test using a tool called RegSuit. Hopefully that sounds interesting to you. Let's get started. First, let me quickly introduce myself. Again, my name is Jesse Katsumata, and I'm currently living in Japan, working as a front-end engineer at a company called Cure App. You can also find me on Twitter or GitHub as Natural Clar. I've been developing React Native for the past 2 years or so, and I absolutely fell in love with it. I've been keeping up with the latest updates, and I've been sending fixes to the community repos and the documents, which eventually got me to joining the React Native community, where I maintain some of the main core modules for React Native. I also love participating in other open source communities in general. It's a great way to learn the internals of the project and expanding my knowledge while helping others. I've been helping out with stuff like Japanese translations of documents for libraries like React, Gatsby.js, and TypeScript, and I've been making small fixes to several repositories, including React Native. The company I work for, Cure App, is a leading medtech startup in Tokyo, Japan. In Cure App, we are building a digital therapeutic apps to provide medical treatment with the power of technology. Our engineers at Cure App, we write everything in TypeScript. That is, we write our web applications using React, our servers are running on Node.js, and even our infrastructures are set up using TypeScript with AWS CDK. And of course, our mobile applications are built using React Native. As our applications deal with humans' well-being, we take our testing very seriously to make sure our apps work the way we intended to. I've mentioned that everything is written in TypeScript, so all our code bases are type safe. We also perform unit tests for the business logics and integration tests for our APIs, and we perform UI testing for our pages and components. For today's session, I'll be focusing more on the UI testing, which the visual regression test takes part in. So the UI testing. When you're working on a big project with multiple people, have you ever felt scared about making changes in a file that already exists? You may think that you've found the right file to solve the particular problem, but you never know if the change will affect something else in your project. Having a test case for your project will let you confidently change any existing file and not worry too much about the effects, as long as the tests are there to protect the code. UI testing is also part of that, and as the name suggests, it aims to test the user interface of an application. It tests the functionalities of parts of application that can be physically seen by the user. Here are some examples of UI testing. If you were to perform a UI testing on a login page of an application, you'd want to make sure that the login page contains all of the aspects for users to be able to log in, no matter what change you make in the code. You'll probably want to have an input form for users' email address, and another input form for users to enter their password, and a login button for users to press once they're done entering their login info. You'd probably also want to verify that the login button is disabled if user's email or password is empty, and it is also nice to test that the login page shows a loading state while the user waits for their verification. And since it's a test for the UI, you'd want to make sure that the login page visually looks the way you intend it to be. As you can see, there are many different aspects of UI testing, and it can be categorized further into different tests like snapshot testing, interaction testing, and today's main topic, the visual regression testing. And let me briefly go through what each of these tests do. Snapshot tests in React or React Native is where you take a component and save the DOM structure of it, so that whenever there's a change to the component, the testing framework can report the difference it made in the DOM structure. Snapshot tests are very useful when you want to see that the particular change you're making only affects the specific page you're trying to change, and it's not affecting any other page unexpectedly. Interaction test takes the page component and emulate what the user would do in the page to make sure that the page performs correctly. For example, if a user tries to log in with an incorrect format of email address, then the user should see an error message and not be able to run the login API. And if the users do enter the correct information, then you'd want to make sure that the information they entered are properly passed down to the API. The interaction tests are useful when making sure the changes in your code are not breaking the user flow. And both snapshot testing and interaction testing can be performed in the React Native projects using testing frameworks like Jest and with tools like React Native Testing Library. React Native Testing Library is an awesome library, so I highly recommend you checking it out. And finally, let me talk about the visual regression test. Unlike the previously mentioned test, which deals with more of a logic part of the code, the visual regression test solely focuses on how the component visually looks. What's displayed on here is an example of test reports generated by the visual regression test. It is showing the change I made in a button component in a way that we can actually see it in our own eyes. You can see that it's showing the diffs of two components, letting you know exactly where the changes are made. And they can also be seen side by side for comparison. How visual regression test works is that first, you take the screenshots of all the pages and components that you want to test, and you store that somewhere you can use as a reference. And every time there's a change made in the component, you take new screenshot of that component and compare that with the reference. And you continue doing that to create visual regression tests. Depending on the visual regression tools you use, I think most of them create reports that, like what's shown on here, every time a pull request is made to the repository. Every report shows the number of components that has changed from the reference, number of new components that are added, or numbers of deleted components if there are any, and number of components that remained unchanged. And once the reviewer checks the report and see that everything is looking the way you expect it to, the reviewer will approve and merge the commit. And once that happens, the visual regression test updates the new screenshot, and the new screenshot will become the new reference. By having these reports, you will be able to prevent any unexpected change that goes into your application, at least in visual-wise. Let me show you a contrived example of how visual regression tests may be useful. Here's yet again a sample sign-up page for your app. And let's say that you have a button in your sign-up page that you feel is a little too small, and you'd like to make it a little bigger so that the user would have an easier time pressing the button. Since the sign-up page is using the primary button component, which takes in a label and displays the button, you go into the primary button component and you see that the width of this button is set to be 150. So you go ahead and change the width of the button to something bigger, like 240, and voila, your sign up page looks the way you want it to be. So then you commit the change and you feel good about yourself, and you're getting ready to go home. But you fail to realize that the primary button was also used in the login page of the app, which has a login button and a register button side by side. Since both of them were using the primary button component that you've changed, now the buttons won't fit on the single screen. When you make pull request, the only change filed was the primary button component. So it may be hard to tell from the first glance that the layout of the login page has changed unexpectedly. If you had the visual regression test set up, then it would create a report for both sign up page as well as the login page, because both of those pages has changed, and you would have been able to tell that the layout of the login page has been broken. That past example can be achieved from a snapshot test as well. You make a change in the primary button component, and it'll cause the snapshot for both sign-up page and the login page to update. So you can catch that you've accidentally changed the layout of the login page. But one thing to note about the visual regression test that makes itself different from the snapshot test is that the visual regression test doesn't care about how component was implemented. That means the visual regression test can prevent false positives that may be created by a snapshot test. In a snapshot test, if you were to make a refactor in your components, like changing your component from a class component to a function component, that will probably require you to update the snapshot, as the DOM structure of the component has changed. Even though the two components may look identical, the snapshot test will change, and you won't know whether the looks of the component changed or not. And another example, if you're using some third-party component library and you want to upgrade the library to the latest version, all your snapshot test of components that depended on that third-party component library may require updating the snapshot. But you have no way of knowing whether the component has changed visually or not. Having visual regression tests will allow you to confidently upgrade your component library and make refactoring to your code with confidence, because it's always taking a screenshot of how the component actually looks in your application even after the change. And also, I want to mention that having these tests set up will help you easily support dark mode with confidence. Let me talk a little about supporting dark mode for your application. With the new Appearance API that has been available since React Native version 62, you're able to check the user's general preference of the app's appearance, allowing you to show the users the app in light mode or dark mode according to their preference. But supporting dark mode means that there are simply twice as many possible screens to verify in your app. And that's how much screens the QAs would need to check. And sometimes, if you're making a change to an already existing app that didn't have light mode or didn't have dark mode, and if you're implementing dark mode, you may forget to apply font colors for a specific part of your dark mode app, making that text unreadable in dark mode. By having visual regression tests for each pages and having tests for both light and dark mode, it will allow you to catch those mistakes rather quickly. So why is it important to perform these visual regression tests? Well, first, It reduces the amount of checks the QA needs to do, so the QAs can focus on finding other bugs in your application. And also, sometimes the difference you make in a component is so small that it is very hard to catch with a human eye. There are a few times where I accidentally entered a character in some pages, and it was caught by the visual regression test. So how do I perform visual regression test with a React Native project? There are probably many different frameworks that allows you to perform visual regression tests, and the one I use for our project is called RegSuit. RegSuit is an open source testing framework for visual regression tests. This tool will allow you to store a series of screenshots of your components in an external cloud storage like AWS S3 or Google Cloud Storage. And every time you make a new pull request in a repository that has RegSuit integrated, it will make a comparison of the screenshots with what's stored on the cloud storage and the new screenshots that you've made. Setting up RegSuit is also very easy. It provides a CLI command that does everything for you. And once it is set up, it will automatically create reports like the one I showed in the previous slides, listing which screenshot has been modified or newly added or deleted on every pull request. And in order for the RegSuit to work, you need to get the screenshot of your applications. For me, I use Storybook to list all my pages and components for my React Native applications. Storybook is a framework that provides a playground to list all your UI components, and it can be ran separately from your main application, so you won't have to wait for your native app to be built. Storybook has support for various front-end web frameworks, including React, and it also has support for the React Native apps. But actually, I don't use the Storybook for React Native. I use the Storybook for React on web, along with React Native for web library. Using the React Native for web with Storybook provides other benefits, as it allows me to write new components much faster, and you don't have to wait for the emulator to start up. But at the same time, it has some downsides as well, because what's displayed on the web isn't exactly what will be displayed on the native applications. And I'm not aware of other tools that takes screenshot from like an Android emulator or iOS emulator. But if there are ways to take screenshot of your screens from the emulators, then those can also be integrated with the RegSuit as well. And that wraps up the explanation of the visual regression tests. Next, I'd like to conclude this session by showing a demo of RegSuit that's actually running. Sorry, trying to get the demo. Okay. Sorry. There you go. Let's get into the demo. Here's the storybook for a minimal design system repository that I made for my React Native projects. Oh, this is not the storybook. Here's the storybook. Here you go. And then it has minimal components, or it has a base level components that are meant to be used to compose component for a bigger project. For this demo's purpose, I'm going to modify this round button outline component and create a new pull request to trigger the RegSuit. So here you go. Here's the round button outline component. It's a simple button component which sets styles with set styles, and it takes in a label for the button to display. And I'm going to change the label part to say React Native is awesome no matter what label prop it receives. And I'm also going to change the border radius a little so the shape of the button will change. And then I'm going to commit these change and create a new pull request. Okay, the pull request is made or going to be made. Okay, and then I'm going to let the CI run for a bit. The CI checks the lint and the typing, and it also performs the visual regression test. And while we're waiting for the visual regression test, let me show you how my CI is being set up. So this is the config file for my CI, and this is the visual regression job that's going to be run. And here at the end, I have a command to take screenshots of all the components and pages from my storybook called StoryCap. And then it will run the RegSuit once the screenshot has been taken. So let me go back to the pull request and see how the CI is doing. And it seems like everything except the visual regression tests are done. And let me check the status of the visual regression test. And it's about to finish. So let me go back. So this is the generated comment for the RegSuit. And it's showing 4 red circles and a bunch of blue circles. The red circle means that there's a change in the component, and the blue circle means that there's no change made. And let's check out the report. All the components that has changed goes on top, and all the components that passed goes on bottom, so you can easily tell which components has changed. And it's nice that you can also look at all the components that has passed as well. It's good for new people in the team to know what components are included in your project. And here's the report screen for each of the components. And you can see here that the left side is the before and the right side is the after. and the text part of the button is changed, and the border radius has also changed. And the RegSuit provides 5 different ways to show the diffs. And this one you can slide to slowly see the difference of the app or the component. And there's also, you can also look at the components side by side. And there's the option to blend the components from before to after. That may help you see where it has changed. And there's also a toggle option. And the diff is it's highlighting all the parts that has changed, so you can easily see where in the component that has changed. And that was the story for the dark mode component. And you can also see that the light mode component has also been changed. And you can also, and here is a small login page that I made, which was using the round button outline component that I just edited. So you can see on this report that it's making report for the login page as well. And it also checks the light mode of the component as well. So yeah, that is how the RegSuit works. And that wraps up the demo and my presentation. The repository for this demo is also written here in case you'd like to see it in action yourself. Thank you for listening to my presentation, and I hope you enjoyed it. Bye-bye.